Hey there, welcome. I wanted to give you a really quick tutorial on measuring the amplitude of small signals with the oscilloscope. So we've got a few different ways to measure small signals, or just measure signals in general. One are the measurement tools that come with the open scope. So under the math tool, you can see I've selected peak to peak. Um, but then there's other ones we could pick too, like we could pick RMS or something like that. And what I wanted to point out is that I've got two signals here. One is the input to a particular circuit, the other is the output. So the blue, the large signal, which has about plus or minus 1.5 volt swing, is that's the input, and then the small signal is the output. So if you're trying to get an estimate of the amplitude of the wave, and if it's the blue wave and it's big, and the noise that's on the input of the oscilloscope is not significant, then what you can do is you can really rely on things like the peak-to-peak voltage. So in this case, the peak-to-peak voltage that the waveform was set to was 3 volts. And here we see that it measures like 3.01, 3.02. I would probably pick the lowest value that you see. However, when we get to the really small signal, right, if we look at the peak to peak, we're seeing numbers that fluctuate around 21, 24, 27, 31, right? But if we look at this waveform and we actually put some cursors on it, what we see is that the waveform is actually much shorter than the peak to peak would suggest, because the peak to peak, what it's going to do is it's going to look across the whole data set and it's going to say where was the smallest negative value, right? And so there's a really small negative value, looks like it's about 4 millivolts. There's one of the taller positive values, it's around 29 millivolts, and for this the peak to peak is 25, so the difference of those two things. But you can tell that that difference doesn't really reflect the actual amplitude of the wave. I mean, you can see that there's a sine wave here, but the noise is pretty big too. So probably a better way to do it would be to use cursors, and so you can stop the waveform and you can try to adjust the cursors and just try to center them in what looks like kind of an oscillation that would be in the middle of the fuzz. And it's not an exact thing, but it's a whole lot more accurate than picking the peak to peak just automatically. And you can see there I've got 7.5 millivolts is the delta Y between the cursors, and compare that to peak, which was saying 25, or RMS, which is giving 17. Both of those are major overestimates of the amplitude, and so really the cursors is going to be your best bet for really small signals. So just keep that in mind when taking measurements for the lab.